Okay, so today let's work on expanding binomial expressions and expanding into a set of brackets when we're multiplying. So let's just do some quick review here first. When we're expanding something that looks like this, so there's a hidden multiplication sign between this two and between the first bracket here. So another way of writing this would be -2 times 3x minus 6. Usually we don't write it out with that time sign because it's implied, because it's assumed that we're multiplying from that -2 into the set of brackets there. Now our method, when we're expanding into the set of brackets, when we multiply this -2 times the 3x, that's one term there, right? Within our set of brackets we have two terms. The first one is 3x, the second one is minus 6. And what we're looking at here, we always notice that what separates our terms within the set of brackets is either a plus sign or a minus sign. We can use that to determine how many terms are within the set of brackets and how many steps we need to take to accomplish what we want to here. So for this first example, like I said, there are two terms, and we're going to first multiply our -2 times the 3x. So this equals -2 times 3x. I'll put both of those in brackets, -2 times 3x. And then here we can do a plus, and we'll multiply the first number, the -2 times the -6 here, plus -2 times -6. Okay, so -2 times 3x here. What I do is I multiply my coefficients, those are the numbers, so I multiply -2 times 3, that equals -6, and then I count up all the x's that I have. I just have the one x, so I leave that as is. And then plus my second term here, which is -2 times -6. Well, negative times a negative, sorry, I'll write that in a little nicer. A negative times a negative is a positive, so -2 times -6 equals +12. So how I expand, so we're finished here. How we have expanded, how we've expanded -2 into this set of brackets is we multiplied it by the first term and then multiplied it by the second term. So we'll try that again for example B. We multiply 5x is the term outside the brackets. We need to remember the x as well. We can't ignore that. And then we have two terms inside the brackets. There's a 2x and there's a 4. So multiplying first 5x times 2x, and then plus, multiplying the second, 5x, don't forget that x, times 4. Well, 5 times 2, we start with the coefficients. 5 times 2 is 10. And then I work with my variables. So I have x times x. Well, x times x is another way of saying x squared. So I have 10x squared here. And then plus, and here I multiply my coefficients first. 5 times 4 is 20. I count up all my x's, I just have the 1, so 20x. Most common mistakes here for these problems are forgetting some of their variables, forgetting some of your x's there. Now let's move on. Let's move on to something a little more complicated. So here I have two sets of brackets, so two binomials. That means two sets of brackets, each with two terms. So my first set of brackets, there are two terms x and 8. My second set of brackets, there are two terms x and 3. Remember, what separates our terms are our plus signs or our minus signs. So here, what we use is something called the FOIL method. F-O-I-L. This stands for first, outside, inside, and last. So when we expand these set of brackets here, what we're going to do is the first thing we do is we multiply the first ones. X times x equals x times x plus, and then so that's the first, then I work the outside terms, meaning this term and this term. They're on the outside of my 4. So plus x times 3 plus, and then I work my inside terms. So 8 and x here, so plus 8 times x. And then I work my last terms, which are x and 3. So plus, x times 3. Now I've shown my multiplication in a different way here. Both are acceptable, this way or the first method that we did above when we used our brackets there. If you prefer the brackets, by all means, stick with your brackets when you're showing what you're doing here. How we'll continue here is we simplify what's remaining. So I have x times x. Well, another way of writing that is x squared. And I have x times 3. So how we're going to write that will be with our coefficient first and our variable second. So that equals 3x. And then I have 8 times x, same way, 8x, and x times 3 plus 3x. And then what we need to do, we're not quite finished here because we notice some of our terms, they look very similar. What we're going to do is we're going to collect like terms, and we've done that before in previous classes. We'll see how well you remember it. What determines if terms are alike is the variable and the exponent involved. So here, all 4 of our terms have the variable x, but only our first term right here has an exponent on it. So that means that this first term is alike only to itself. It's unique here. But the following 3 terms are all alike to one another. So those we can combine and collect. So let's start off. So we'll leave our x squared alone because it's unique. And then I have 3x here. 3x is here. That's 3 times x. And I have 8x is here. 8 times x. And 3x is here. So what I can do is I can add those up. 3 plus 8 plus 3. That's 14x. That's how I collect my like terms, and that is what my final answer should look like. Now we'll try that same strategy. We'll try that FOIL strategy for the second, for the second part of the example here. So we'll start with the first ones. That's 2x times 3x. Then we'll go to our outside terms. That's 2x and 5, so plus 2x times 5. Oops, back it there. Plus our inside terms, that's 1 and 3x here. Plus our last terms. That's our last terms, which are 1 and 5. So plus 1 times 5. Now we'll multiply our individual parts here. So I have 2 times 3 is 6, and I have x times x, which is x squared, plus I have 2 times 5, which is 10, and I just have the 1x, so 10x, plus I have here 1 times 3 is 3, and I just have the 1x, so 3x, plus 1 times 5 is 5, and there are no x's there, so the 5 is on its own. It's a coefficient. And we can collect like terms. I can see right away that my x squared is unique. There's only one term with that. But my x's are alike, and I can see that my coefficient here is unique. So when I'm collecting those like terms, I have 6x squared plus 10 plus 3, so that's 13 x's plus 5, and that is what my final answer should look like. We'll try this same strategy here for 2c. The difference is I have a negative term here, so we'll see what happens when we work through it. We'll start off with our first terms. That's x times x. I always do my plus sign in between. My outside terms, which are x and 3, plus my inside terms, which are here. So how I'm going to work with it here is my inside terms here. The first one is negative 4. I'm going to keep that minus sign in front of it and use that. So negative 4 times x. And then my last terms, again, we're going to work with the negative 4 and the 3. So plus negative 4 times 3. So I multiply my first term here, so x squared plus, then I have 3 times x. I'll write the coefficient first. And then I have minus 4 times x. So I'm going to put a minus sign here. Minus 4x. And I have minus 4 times 3. Again, so it's a negative times a positive. That equals negative 12. And then I will collect like terms. My x squared is unique. My x's are like terms. And my coefficient here is unique. So that equals x squared. And then I have 3 x's minus 4 x's. So in total that's negative 1x. Another way of writing that is negative x. And minus 12. That's a unique term there as our coefficient. Like I said, I can rewrite this as x squared minus x minus 12. That's what it should look like. And we'll move right on to D. Here we have, again, a negative term here. It's the negative 1. So D, I'm going to work with my first terms. That's 5x times x plus my outside terms, which is 5x times negative 1, plus my inside terms, which is 2 times x, plus my last terms, which is 2 times negative 1. So we'll pull them all together here. I have only one coefficient here. Remember, there's a hidden coefficient before this x, and that's a 1. Oops. The hidden coefficient there is a 1. That equals 5 times 1, which is 5. And then I have an x and an x, so that's 5x squared. And I have 5 times negative 1, which is negative 5, so I'll put my negative sign here. Negative 5 times x, because I only have the one x. Then I have plus 2x, that's right here. And negative 1 times 2, or 2 times negative 1, that's negative 2. So I'm going to subtract 2 here. Again, I can collect like terms. You'll notice a pattern here when we're working with binomials of this form, then our middle two terms will be alike that we're collecting here. So 5x squared minus 5x plus 2x, that's negative 3x minus 2. And this one's interesting. let's rewrite this. Because it's something squared, its base, which is x minus 4, times itself. So x minus 4 times x minus 4. That's the first step. And then we can continue as we have. We're going to use still first, outside, inside, last. So we'll start with our first ones here. That's x times x plus outside terms, which are x and negative 4, plus our inside terms, which are negative 4 and x, plus our last terms, which are negative 4 times negative 4. X times x is x squared. And then I see I have a negative 4 times x, so that's going to be minus 4x. I have a negative 4 times x again, so minus 4x. And a negative 4 times negative 4, I know a negative times a negative is a positive, so plus 16. Again, I have my like terms in the middle here, so I can collect them, x squared, and then I have negative 4 minus negative 4 x's. So negative 4 x's minus 4 x's, which is negative 8 x's, plus 16. And finally, here we notice we have the same kind of, for question F, we notice we have the same kind of question as we had here for question E, except this time there's an extra term at the end, there's a minus 7. So we're going to leave that alone until the very end here. So just like before, we'll expand our exponent here. So 3x plus 2, 3x plus 2, and then minus 7. So I'm going to carry that minus 7 down. This equals my first, which is 3x times 3x. My outside, which are plus 3x plus 2. My inside terms, which are 2 and 3x. And my last terms, which are plus 2 and plus 2. So plus 2 times 2. And I can't forget, carry down, minus. Carry down my minus 7 there. So now I'm combining these, I'm multiplying, so 3x times 3x, that's 3 times 3, which is 9, and then x times x, which is x squared. And then I have, forgot some brackets here. 3x times positive 2, 3x times 2, which is 6x. And then I have 2 times 3x, which is the same thing, that's 6x. And 2 times 2, which is 4. And then again, I need to carry down my final term, minus 7. Now I can collect my like terms. I have my first two terms there. And actually, I see two more like terms that have popped up. That's plus 4 and minus 7 there. So this equals 9x squared, that's still a unique term, plus 6x, which is 12x, plus 4 minus 7, which is minus 3. So that's how it looks here. Now you might notice that we have worked with something similar to this in the past. This form here, this is vertex form. So this is the form of a quadratic. If it says y equals 3x plus 2 squared minus 7, then I would know that my h equals negative 2. I would know that my k equals negative 7, and my vertex is at negative 2, negative 7. So this is a quadratic. Now we're not graphing it right now, so we don't necessarily need to know that, but just remember what we've been able to do here is we had something that was vertex form, and we've changed it. We've completely changed it to a different form here. And what we call this at the bottom, our final answer, is standard form. That's why the node is called what it is. So that will be more useful later. You don't necessarily need to remember that this is standard form, but this is what happens when we are expanding the brackets and then simplifying by collecting like terms. So we should be able to do that now.